Today we're going to be talking about lesson 8.4, which is on vectors in three-dimensional spaces. So we know about the x-axis, the y-axis. We now have what's called the z-axis. And this is what makes up the three-dimensional coordinate plane system. So previously, if you know about the two axes, you have 4 quadrants that you can find points in. Quadrant 1, 2, 3, 4. But once you get to a third axis, you end up having 8 regions called octants. So go from quadrants to octants, and they're made up by using this plane right here. Now the one thing that was odd to me the first time I saw it, and maybe it's odd to you, is that the x-axis is actually this axis, the y-axis is this one, and z is up and down. You think it's easy, and it's just going to be adding the z-axis across, but it's actually not that simple. So how we plot a point is called an ordered triple, x, y, z. So the order in which a ordered triple is still the same as x, y, we just add z to it. But instead of going over, up, we now actually go forward or backward, over left or right, then up or down in the three-dimensional quadrant plane. So it says plot each point in the three-dimensional coordinate system. So I need to draw my system. It'll look like this. Reminding ourselves that this is the x-axis, this is y, and this is the z-axis. Okay? So if I make some system like this, okay, now I'm going to plot my point. So first, I have 4, 6, 2. So I'm going to go forward 1, 2, 3, 4 spaces. Then I'm going to go over 6 spaces. Now here's what's a little bit goofy about it, is the fact that you actually have to go over 6 from right here, not over starting at 0. So I'm going to count over 1, 2, 3, 4, 5, 6 is right there. And then finally, I need to go up 2. So then I move up 1, 2. There is my point right there. Okay? So just as a review, okay, I first went forward 4, then I went to the right 6, including the 4 that I went forward, and then I went up 2 to end at this point right here. Okay? If I was going to do the same for my next problem, I make my coordinate plane. Okay? Remember I have x, y, and z plane. Okay? Okay? So if I'm going to plot my point, -2 would mean I go back 2, then I go over 4 to the right, so 1, 2, 3, and here's 4, and then down 5. So 1, 2, 3, 4, 5 is going to be right here. So remember, I first went back 2, then to the right 4, and then down 5. And here's my point right here. And I'd label it as -2, 4, -5. Here's a couple problems you could try as guided practice. Now, distance and midpoint formulas for ordered triples is the same. You just add on z in both of them. So it's no different than what we've already learned before using 2 axis points. So it says, a tour of the Sierra Madre Mountains lets guests experience nature by ziplining from one platform to another over scenic surroundings. 2 platforms that are connected by zipline are represented by the coordinates 10, 12, 50 and 70, 92, 30, where the coordinates are given in feet. Find the length of the zipline needed to connect to the 2 platforms. So if we know those 2 points right there, we simply need to find the distance formula between them. Remember, distance for 3 points is x2 minus x1 squared, y2 minus y1 squared, z2 minus z1 squared. and I'll just fill in my numbers as I see them. Okay, so I would do 70 minus 10 squared, 92 minus 12 squared, and 30 minus 50 squared. In the sake of time, we'll just put that into our calculator, and we end up finding our answer is approximately 101.98 feet, which you could also round to 102 feet if you saw fit. Part B says an additional platform is to be built halfway between the existing platforms. Find the coordinate of the new platform. So this is asking us to find the midpoint between all of those. So remember, midpoint is x1 plus x2 over 2, y1 plus y2 divided by 2, and z1 plus z2 divided by 2. So we'll just put in our points again from our original ordered triple. 10 plus 70 divided by 2, 12 plus 92 divided by 2, and 50 plus 30 divided by 2. So my answer, my ordered triple, is going to be, well, 10 plus 70 is 80 divided by 2 is 40. 12 plus 92 is 104 divided by 2 is 52. And 50 plus 30 is 80 divided by 2 is 40. So the location of that platform in the middle would be 40, 52, 40. Here's a guided practice problem you can try on your own that includes two planes flying above the city of Cleveland. Now we learned how to graph ordered triples so that we can apply them to vectors. So example C3 says to find the vector v that has the coordinates 3, 4, negative 2. So just like we did before, I can plot my vector in 3 dimensions similarly to how we did it in 2 dimensions, just like how we did it plotting points. So first off, my x component is 3. So I go forward 1, 2, 3. And then my y component is over 4. So I go over 1, 2, 3, 4. And finally, my z component is now down 2. So 1, 2. So this right here is the location of my vector starting at the origin. So there is my vector v right there. And you can try the same with the guided practice problems as well.